Hi, my name is Daniel Aguirre, and today I wanted to give an example of test-driven development using FizzBuzz. So first, I'll talk a little bit about what test-driven development is. Essentially, test-driven development is a methodology or practice of creating the test using the requirements for your application or method or whatever it is that you're working on before actually creating the implementation. So essentially, maybe your endpoint or method, whatever it is that you're working on, needs to be able to take a few different things into consideration. There's a few different expectations that you have when you call that method. And so each of those is the requirement, and we would create different tests to assert that we are meeting those requirements and create the logic, the implementation to pass each one of those requirements or tests one at a time, and then continue on looping back and forth between creating the tests and the implementation to pass the test. So the example that we'll be using, I believe I mentioned, was FizzBuzz. If you're not familiar with that, essentially it is a kind of coding challenge where maybe you are given a number, for example, 15, and you want to return for each number, maybe if it is divisible by 3, then you would return fizz. If it is divisible by 5, then you would return buzz. And if it is divisible by both 3 and 5, then you would return FizzBuzz. And for this case, we'll just say anything else. We'll return the number as it is. So like 1 or 2, we would just return a 1 or a 2. And then 3 would return fizz, 5 would return buzz, 6 would be fizz again. We'll skip forward to 10 would be buzz, and then skip forward again, 15 would be FizzBuzz, since it's divisible by both 3 and 5. So we'll go ahead and get started. I will share my screen, and we're going to create a new project, which will be a class library. And we'll just go ahead and call it FizzBuzz. All right. And I'll be using .NET 6 for this example today. Let's see here, we can remove this default class, and we will create a new class. We'll just call it Fizz. We'll make it a public class. And then we'll go ahead and just define our method now. I'll go ahead and say, it's going to be public, and maybe it'll return a string array. So maybe if we give it the number 5, then I would expect it to return 5 strings back to me. And each string would follow those rules we defined earlier of either being the number as it is, or if it is divisible by 3 being fizz, if it's divisible by 5 being buzz, and if it's divisible by both being FizzBuzz. So we'll say public string array. We'll just call it FizzBuzz. And again, we're going to take in an int, number of elements is what we'll call it, for however many numbers or fizz, buzz, whatever we're going to have in there. For now, we'll just go ahead and throw a new non-implemented exception. All right, so that looks good. We're going to go ahead and create a test project so that we can go ahead and assert, that everything is being done properly. And we'll just call that fizzbuzz.test. And again, we'll use .NET 6. I'll remove this default unit test 1 class and just create a new one from scratch. And I'll call it fizz buzz test. All right, start off by making it public. And then we're also going to need to, since I'm using in-unit for my testing framework, I'm going to use annotations. for test fixture, let it know that this is going to be a class that holds tests. And we'll go ahead and start with creating a test. And we'll say public void FizzBuzz, since that's the name of our method, given number returns, we'll say should return string array, same length as number. All right, so we'll say if we give it a number, then it should return a string array that has the same length as the number, right? So we'll go ahead and start by saying we have this public class fizz. It is non-static, which means we will need to create an instance of it. So we'll say var fizz equals new FizzBuzz. Oh, whoops, fizz. And there actually is another issue that we have here, and that is our Visual Studios cannot find our fizz class. So the reason for that is because this FizzBuzz, the fizz class exists here within the FizzBuzz project, that separate class library. So we haven't told our test project that the class library is out there and that it can depend on that class library. So we'll go ahead and right click on our fizzbuzz.test and add a project reference. And that is going to tell our test project that it can refer to our FizzBuzz. It can depend on that project. And since we can depend on it, we can go ahead and use that fizz class. So var fizz equals new fizz. And we'll say var result equals fizz dot FizzBuzz, and for now we'll just pass in 3. And you know, Visual Studios wants us to use this to start our equal 3 result. I personally actually like to use another framework, which I'm going to go ahead and introduce here. So I'll go to manage NuGet packages, and I'm going to install Shouldly. And the reason why is because I really like this package. It actually makes it feel like you're reading more regular English or regular sentences, I feel like. So maybe you'll feel like that more as you see me working with it throughout here. But essentially, I'm going to go to our NuGet package manager here, look for Shouldly, SHOULDLY. I had trouble finding it because I misspelled it. So make sure you get that right. But yeah, what we're going to do instead here is we're going to say results dot length dot should be, and we'll go ahead and use that, add that using statement for shouldly there. And we'll say that it should be, for now we'll say 3. We're going to refactor this in a minute. But yeah, so essentially we're saying, hey, go ahead and call that method, and we're going to give you a number, and you should return a string array that's the same length as the number. Like, that's my first requirement for FizzBuzz. We have more requirements to come, but we're going to go ahead and create an instance of it, and then we'll call the method, and I'm going to say, hey, your length should be the number that I provided you. So that looks good. Let's go ahead and just make sure that, you know, it works. So first thing you want to do every time you create a test is run it and make sure that it fails, because if it doesn't fail, then you've done something wrong. Right now, I should be receiving a throw new not implemented exception, right? So that's exactly what we're getting here. Method or operation is not implemented because that's what we told it to do here. So we know that my test is doing exactly what I expect it to do. It is calling the method, and it is failing because I haven't created that logic yet. So let's go ahead and fix that. And what we'll do is we will say return enumerable.range, and we're going to start at 1, and we're going to pass in the number of elements. So if you're not familiar with the enumerable.range, this is something we're able to use here through link. And the range method is going to take in the first number is where you're going to start. So here we're going to start at 1. And we're going to give a number. Maybe we give 3. So we'll have 1, 2, 3. Or if you give it 15, we'll have 1 through 15. You could give it a different number to start at, but it's then going to go ahead and take that count and go up from there. So we're going to go ahead and create a enumerable.range, and this is returning an IEnumerable of integers, but I want strings. So what I'll do is I'll use another link method .select, and I'm going to select each number, and we'll just call it X, and we'll say X.toString. And Visual Studios is going to cheat here and tell us the rest of it, but I'll go one step at a time and say, we're going to transform it, and we are going to say, hey, each number we are going to transform into a string. Now, this .select method, again, that's another link method, and it is returning an IEnumerable of string now. So we went from IEnumerable of integer to IEnumerable of string. So our FizzBuzz method is expecting us to return a string array. So we need to go ahead and make sure that we change, even though a string array does implement the IEnumerable interface, we need to go ahead and convert that back to a string array to return for our method. So we'll go ahead and say .toArray that it had there earlier for us. And we can go ahead and test our method. And we'll go ahead and see if we're passing, which we are. That's great. That's awesome. So take a look, and we're going to refactor this a little bit. 1, I don't really like the magic number in here. We've got 3. Maybe we could create that. Let's kind of expand on this and create more tests out of just 1. Instead of us just testing that it works with 3, we could use, well, let's put it inside annotations, and we'll say test case. And we'll pass in that 3. And we'll say int number of elements, just to go with what we had in our method. It doesn't have to match, but just for consistency, because that's always good. So our number of elements. So FizzBuzz given number should return string array, same length, that's number. We're going to pass in that number of elements, and we're going to assert that the result.length should be the number of elements. All right, so now we could go ahead and run that, and this is exactly the same exact test that we had before. So now what we could do is we could add a bunch more on here, and we could say, like, maybe we want to do 5 and 6 and 12 and 24 and 30 and 36. All right, cool. So now we have a bunch of different tests there. And we're going to just make sure that no matter, doesn't matter what number we give our method here, we should be working, and we are. That's great. And you can actually open it up and see each individual one. So maybe if you were failing for a certain one, then you would be able to find the one that you're failing for and find out, like, hey, why is it when I give this specific input, I gave the number 5 and it broke when I gave that number. Let's debug that specific one, right? But let's go ahead and go on, and we'll say public void FizzBuzz. Our next requirement, right? We mentioned that if we're given a number that's divisible by 3, then it should return fizz, right? So public void FizzBuzz given number divisible by 3 should return fizz. And what I'll do is I will go ahead and maybe for now, I'll just create one, right? We'll do the same thing again. We'll say var fizz equals new fizz. And then we'll say var result equals fizz.fizzbuzz, but maybe this time, well, I guess we'll put in 3 like we did last time. We'll change that again in a minute. And we'll say, instead of looking at the length this time, right, we want to say the result.last, right? And I'm not worried about using last or default. If you're not familiar with the difference between last and last or default will return null for me if there is no actual elements. Like let's say I try to say the last or default and it's an empty array, then it can't give me the last one. The last one doesn't exist at all because it's null, right? So I could use that to get null, but here, I'm creating this test. I know that I should be getting, it's not going to be null, so I'm not worried about that. I'll just use last. And the last one, let's see, this is going to go ahead and return a string for us for whichever one was last, and we'll say that it should be, right? And we expect it to be fizz. Okay. So that's should return fizz. Number divisible by 3 should return fizz. And we'll go ahead and test that. Actually, and you'll notice it's not showing up in my test explorer. And the reason for that is because I forgot my annotation. So always make sure that you have your annotations there. Otherwise, your test explorer is not going to show up with your test. So if you're ever trying to find your test and you're going crazy, can't find it, make sure you have that data annotation. So we've got that added in here now. We'll go ahead and run that test. No, we're failing. That's good because we haven't created that implementation, right? We're getting 3. And we're expecting fizz. So what we'll go ahead and do is we'll come in here and create our logic. So maybe what I'll do is I'll look at each one and now in this case, let's see, it's going to be a number, right? So I could say maybe x modulus 3 is equal to 0, right? Because if it is divisible by 3, then we want to output fizz. And if it's not divisible by 3, then we'll go ahead and output string. So if this is getting a little bit hard to read, let's maybe go ahead and break it up a little bit, and we'll just do something like that, right? And maybe if that's still hard to read, we'll just break that ternary up. So we'll say we're going to select each one, each number, and if the number is divisible by 3, then we are going to output fizz. Otherwise, we will output the string. And if this is all completely new to you, if you've never seen this before, this is what would be called a ternary. So basically, it is an if-else statement that you can use to return a value, return or assign. So essentially, we are going to go ahead and first pass in a condition, in which case we are going to check x, or the number, modulus 3 is equal to 0. So that's a true or false statement. And if that is true, then we will output the first value. And if it is false, then we will come after this colon and we will output the second value. So our first value, if it is divisible by 3, will be fizz. Our second value, if it is not divisible by 3, will be the number itself. All right. So we'll go ahead and come back to our test. Go ahead and run that. And awesome, that's great. Maybe now that we know we're passing, let's just go ahead and say like int number. We'll just keep it going with the number of elements. Let's go ahead and come up here. We'll say, whoops, test case, we'll say 3. We'll say 6, and then 9 and 12. So those are all divisible by 3, right? So the last index of all of those should be divisible by 3. So the last one should be fizz for all of these test cases that we have now just added. And so let's just go ahead and give it another test, make sure that everything looks good, and it does. We're passing for 3, 6, 9, and 12. So let's take a look at the next requirement, which is that, so test, we'll say public void FizzBuzz given number divisible by 5 should return buzz. Right? And let's just do it. We'll do it without having to refactor it afterwards this time. We'll go ahead and say, come up here. We'll say 5. 10. I'll skip 15 since we know that it is divisible by both, and we'll say 20. And 25. And we're going to do like the same thing here again, right? But, we're repeating some logic here, and maybe that means that there's, a quicker and better way that we could do something, right? We're having to initialize an instance of our fizz class in every method. So maybe we could shorten some things up. We've done a couple of tests here, so it's a good moment to take a chance and see if we can refactor. So let's create a private fizz. And since it's a private field, we'll use underscore, and we'll call it underscore fizz. And we'll just say that it equals new fizz. Right. So we went ahead and created a private field for that, and we also initialized it, right? So there's a couple ways you could do that. You could also have constructor, and you could say fizz equals new fizz, right? And then take that part out, maybe add your get set or whatever. But what we'll do is, just to make it shorter, is we'll have equals new fizz. So if you weren't familiar with using that and the difference between having it in the constructor and having it there, it's pretty much the same, because when you create a constructor, unless you have multiple different constructors, maybe you have a default constructor and a custom one that takes in parameters, then maybe that'd be different, because this will happen every time that I initialize a class. This is what's going to happen when I use this constructor. So for now, we're just going to use this, keep it simple. So we'll say private fizz underscore fizz equals new fizz. Now let's just go ahead and take that line out, and we'll say underscore, right? And if you really wanted to make it shorter, you could actually come in here and you could say dot length dot should be number of elements, and then take this whole beginning part out, and now you have really short test. So, it looks like this one that we refactored earlier, I didn't even actually add that in to test them, I guess. So we'll go ahead and add that in there now then. And we'll say dot last dot should be, we'll say fizz. I'll get rid of that again. There. All right, so we've taken a moment and have now refactored our tests, and we can go ahead and continue on with kind of the same thing that we've been doing now. So we'll say fizz.fizzbuzz. We'll pass in the number of elements that we're testing with, and this time we're going to say that the last one should be FizzBuzz. And, I mentioned earlier that the reason why I wanted to use shouldly is because I felt like it reads more like English. And if you take a moment to read my test here, we're saying FizzBuzz, number of elements, last should be fizz. And, maybe I could reword my test a little bit better to go with it here. Or maybe you could imagine another scenario where we're not grabbing the last one. Up here is a better example where we say FizzBuzz, number of lengths dot length should be number of elements. So you can see how this would be a little bit easier to read than assert dot r equal, FizzBuzz number of elements, and then, comma number of elements. So I personally think it's great, but we've got this set up here. We'll go ahead and take out fizz since we're actually only asserting that it should be buzz. And we'll run that test. And we are failing because it should be buzz, but it was 10. So we're outputting the number as it is. We're not doing the implementation yet. So we'll go ahead and add in here. Maybe we'll say, was it divisible by 3? Yes. We'll do fizz. No. Well, then let's go ahead and maybe add in here. Was it divisible by 5? Right? And if it was, then we will do buzz. And if it was not, then we'll go ahead and do the string as it was. So kind of building off of the ternary there. And, I wouldn't actually do this in working project because obviously this is not that easy to read if you don't know what's going on, and we're not building it one step at a time. So I wouldn't recommend doing nested ternaries here, but just to kind of make this part go by quick and focus on the test, we'll continue on. And so we've created the requirements, the test to match our requirements here kind of one at a time, and said, FizzBuzz given a number should return a string array that's the same length that's the number that we provided. That's our first requirement. Our second requirement is that if a number is divisible by 3, it should return fizz. And we're asserting that by checking the last number each time we're given a number divisible by 3. And then we'll follow that same kind of testing logic, checking the last one when given a number that's divisible by 5, so that we can assert that it is returning buzz. So now we'll go ahead and do our last one for, we'll say test case, and we'll say 15. And I'll just double it up, make it easy, 30. 45 and public void FizzBuzz. I can type given number divisible by 3 and 5 should return FizzBuzz. Number of elements. All right, and we'll say fizz.fizzbuzz number of elements dot last dot should be, and we'll say that it should be FizzBuzz. All right, and we'll go ahead and run our test, make sure that we're failing as we should be. They should be returning the number as they are, or maybe they're returning buzz, I guess, or just fizz, it looks like. Yeah, so it's returning just fizz because that's our first check, right? So first we're checking, is it divisible by 3? And it was, so we return fizz without looking any further. So before we go ahead and return fizz without looking any further, we need to actually go ahead and also look, is x divisible by 5 also? And if x is divisible by 5 also, then we will go ahead and do FizzBuzz. Otherwise, we'll just do fizz because it was only divisible by 3. And then if it was not divisible by 5, right, it would do fizz. And if it was not divisible by 3, then it would come back here and it would check, well, was it only divisible by 5? Because, you know, just because it wasn't divisible by 3, you know, we didn't even check up here. So let's go ahead and check that. And if it was only divisible by 5, but not 3, we'll do buzz. Otherwise, we'll go ahead and just do the number as it is. So let's go ahead and run our test. And there we go. So I hope you enjoyed this. This was kind of just an example of how test-driven development may be shown, kind of using FizzBuzz. So basically, whenever you're working on something and you have a set of requirements, you can try to break those requirements down and say, okay, well, here's the first part that I'm worried about. I know that in this specific scenario, I need this result to happen every time in that scenario. Then go ahead, create a test for that, and then build your logic to pass that test. And then once you're passing that test for that one piece, that one requirement, you can go ahead and start working towards your next requirement. And all along the way, you can continue, you know, we actually just ran one test at a time here, but I actually would normally be running all of the tests and making sure that all along the way, you want to make sure that if anything happens, changes what you did before, you want to know that everything's still working the way that it should be. So test-driven development is a really great tool because it gives you the confidence to know that even if I came in here and I refactored all of this, I said, hey, this is horrible. I can't read what's going on here. I want to be able to read it easier. Just break it down into maybe a switch statement or some if else's. Then I could do that and I could just run all of my tests again. And I know everything works the way it's supposed to. So that's the really great benefit of test-driven development. I hope you enjoyed this exercise or example, and I would love any feedback you have. Thank you and have a great day.